by graphing and by substitution. And in both cases, it was very helpful for the equations to be written in slope-intercept form. So all the equations said y equals, for example, y equals x plus 1, y equals negative 2x minus 4. Not every time our systems of equations going to be written in slope-intercept form. And if they're not written in slope-intercept form, using the method of graphing or substitution would require extra work because both of our equations would need to be written in the form of y equals mx plus b. So we have other methods that we can use for solving systems of equations, and they're most helpful when the equations are written in what's called standard form. All 6 of the equations that I have on the screen right now are written in standard form. So you can hopefully see the difference compared to y equals mx plus b. The x and the y are on the same side of the equal sign, and the constant is on the other side. The method that we're going to be looking at today is solving systems using elimination. And when you have equations that have 2 variables in them, the only way to solve for the variables is 2 variables requires you to have 2 equations. But in order for us to find out the value of one of the variables, we have to eliminate the other. So that's what this system is going to allow us to do. It's going to allow us to be able to add 2 equations together so that when we do this, whoops, one of our variables is eliminated. Now, the nice thing about the system that I have here in the black is that the numbers in front of the y are exactly the same numbers. They're both 3's, but the signs are opposites. One has a positive and one has a negative. And I think we all know what happens when we add together 2 opposites. We end up with a value of 0. So that's why we're going to add these 2 equations together. We're going to add them together to eliminate the y value for temporarily. So when I add 2x to 1x, I get 3x, and I just keep those x's in line. When I add 3y to negative 3y, I get 0, so I don't write anything for them at all. And normally I would put this really close to the 3x, but because the tail on the y is hanging there, I'm just going to put 3x equals 12 over here. So really my equation right now is down to 3x equals 12. And this takes us way back to the first video that we did, the first topic that we covered here in math, and that was solving these equations. So because x is being multiplied by 3, I have to divide by 3, and I find out that x is 4. I'm half done. I know you're happy to hear that. Right now I found the value for x. I need to find the value for y. And at this point you have a choice. You can put, we're going to go back to substituting, and we can substitute the value of x into either of the 2 equations that we want. I'm going to go with the second one, x minus 3y equals 3. And in that equation, wherever you see an x, you're going to change it to a 4, because for this system, you know now that x has to be a 4. So 4 minus 3y equals 3. Now the only variable I have in this equation is a y, and I can solve for y. And again, it's going to take us back to our solving equations rules that we had to do before. We need to undo adding and subtracting first. And because 4 is positive, I'm going to subtract a 4 from both sides. 4 minus 4 is 0. I'm left with negative 3y equals negative 1. Divide both sides by negative 3. And I end up with a positive 1/3. So I've got 4 1/3. You can check any answer that you get in these systems. I'll leave some space here. It's going to be kind of close. This part over here will be where I'm going to check it if I have the space. That's kind of the nice thing about solving systems. You always have a way to make sure that the answers you got are correct. If 4 1/3 truly is the solution to this system, when I plug a 4 in for x and a 1/3 in for y, I should get a true statement when I'm done. Because I have 9 on the right, this stuff over here should equal 9 when you add it together. 2 times 4 is 8. 1/3 times 3, or 1/3 of 3, is 1. Does 8 plus 1 equal 9? Yes. Whoops. That's supposed to be an equal sign. Okay, and then also in the second equation, if I were to plug the 4 in for the x, 1/3 in for y, I should have a true statement. I should get the same value on the left as I have on the right. 1/3 of 3 again is 1. And does 4 minus 1 equal 3? Sure it does. So we know that this ordered pair is definitely the solution for that system. Okay, the second system, in blue, again, I do have a variable. It doesn't have to be both, but I do have one of the variables that have the same number in front of them. And the nice thing is they have opposite signs. One's a negative, one's a positive. So I'm going to add these two equations together. And I do that just going up and down. Negative 1x plus x is 0, and the x's disappear for the time being. 3y plus 1y is 4y. And I have to remember to add these over here as well, the constants. 7 plus 1 is 8. So now I have an equation that only has a y in it. I can solve for y if I divide both sides by 4. And I find out that y is equal to 2. And now is when I go back to substitution. And again, I have the choice. I can substitute into the first equation, or I can substitute into the second equation. I'm going to choose the second one because there are no negatives in there. And so if I can avoid making mistakes with negatives, then I do that. And because y is equal to 2 for this system, I change the y in the second equation to a 2. X plus 2 equals 1, so I'm going to subtract 2 from both sides, and x equals negative 1. So according to this, my solution for this system is negative 1, 2. And again, we can check it. Opposite of x, well, x is a negative 1, plus 3 times 2. Does that equal 7? And the opposite of negative 1 is a 1. 3 times 2 is 6. So the question is, does 1 plus 6 equal 7? Yes, it does. How about in the second equation? Negative 1 plus 2, does that equal 1? Negative 1 plus 2 is 1. Does 1 equal 1? Yes, it does. So we know that this is the one and only point that works in both of those equations. There would be no other combination of points that would work in both of them. Okay, the third system, the purple one. If I look at the y's, I do see that the y's have the same number in front. The only problem is that they're not opposites, though. I like to have a pair of opposites. That way, all I have to do is add my two equations together. Some textbooks or some teachers will teach that you can subtract your two equations as well. I just like to add. I don't like to have to worry about subtracting. So in order for me to get these equations so that I can add them and have one of the variables disappear, I need to create a pair of opposites. How you're going to do that is to pick one of the equations and multiply the entire equation by a negative 1. As long as I do the same thing to both sides of the equal sign, it doesn't matter what I do to the equation. I could multiply by negative 1,000 if it helped me, but I have to do it to both sides. So I'm going to take this first equation, this top one, and I'm going to multiply everything by a negative 1. Whoops. And when I multiply a negative by a negative, it becomes a positive. And now I'm going to take my two equations, and just like I did in the last two problems, I'm going to add these together. When I add a negative 3 and a positive 2, I get a negative 1. When I add a negative 4y and a positive 4y, I get 0. That's why we changed this to the opposite, so that would happen. And when I add negative 5 to positive 8, I get positive 3. Now over here, I don't want to know what negative x is, though. I want to know what positive x is. So I'm going to divide both sides by negative 1, and I find out that x equals negative 3. And let's see. I don't want to put that there. We'll leave that for where we're going to check. So down here, x equals -3. Okay, now I can choose to substitute that x into either equation that I want. I'm just going to go with the bottom one because I haven't made any changes to that or messed it up in any way. So 2 times -3 plus 4 times y, whoops, equals -5. I'm going to use this to help me find the value for y. 2 times -3 is -6. Now to get the y alone, I'm going to have to add 6 to both sides. That'll be 0. Whoop. And this will be just 4y. -5 plus 6 is a positive 1. Divide both sides by 4, and I'm left with y equals 1/4. And let's see here. If I wanted to check this, and I'm not going to require that you check every problem, if people seem to be struggling with this and it's not connecting, then I might require that you check. Now what I'm doing is I'm going back to the very original problem. It's supposed to equal -8. I'm checking to see if this works. 3 times -3, that's -9. 1/4 of 4, that's a 1. Does -9 plus 1 equal -8? Sure it does. So it works in the first equation. Now I'm going to check my solution in the second equation. 2 times -3 plus 4 times 1/4. Does that equal -5? Well, 2 times -3 is -6. 1/4 of 4, that's 1. Does -6 plus 1 equal -5? Yes, it does. So we do know that our ordered pair does work. That is the solution to that system. Sometimes what might happen, I know this one's getting a little bit long, but I do want to share one instance with you. Okay, so if we had the system and we didn't really, let's say we didn't really look at the equations and think about them at first, and we did what we know we're supposed to do. We took one of the, because we don't have a pair of opposites here, we've got a 3 in front of the x in both cases, a 4 in front of the y in both cases, but we don't have any opposites. So we're going to take one of these equations and we're going to make everything in it multiplied by a -1. Now we have a pair of opposites, and we add our equations together, and when we do that, -3x plus 3x is 0. -4y plus 4y is 0. 0 plus 0 is 0. We don't have anything left on the left-hand side. A lot of times my students will stop there and say, oh no, I did something wrong. I ended up with 0. No, you didn't do anything wrong. -7 plus 12 is 5. Does 0 equal 5? No, it doesn't. So what this means is this problem has no solution. There is no ordered pair that will work in both of these equations. The reason is if we went and graphed these lines would be parallel lines. They would never cross. And the whole purpose of solving systems is to find out the place where the two lines cross. If they never cross, there is no solution. Now, had we looked at the equations to begin with, one equation said that 3x plus 4y was equal to 7. The other equation said that 3x plus 4y is equal to 12. How can you have the same amount, 3x plus 4y and 3x plus 4y, be equal to two different things? 3x plus 4y is 7, and then the next equation says 3x plus 4y is 12. It doesn't make sense that one quantity can be equal to two different amounts. So that's why this ended up being no solution. One other possibility here, quick. What if we had exactly the same equations? Now you guys should know what happens when you have two equations that are exactly the same and you look at their graphs. They end up lying on the same line. But let's say you didn't think about any of that before you started solving this and you just went right to work. You said, okay, I'm going to make one of these equations opposite since I don't have any opposites. That's what Mrs. Fisher said to do. When I add these together, I get 0. 7 minus 7, that's 0. I must have really messed something up this time because everything's 0. No, you didn't. Does 0 equal 0? Yes, it does. And this is a true statement. So because there's no variables left, that means we have many solutions. So those are the different scenarios that could come out. You can get one solution, you can get no solutions, or you can get many solutions.